Okay, guys, we are wrapping it up. We are going to do chapters 9 and 10. We're not going to do chapter 12 because you guys just finished that, and I don't think you need to review it right away, and it's just kind of easier concepts than the rest of it anyway. So we are going to get going on chapter 9 here. This first stuff is writing a recursive and explicit. It says definition, formula, same thing, for each sequence, and then find A of 10. So the first one we're skipping. Number 2, if you look at what we're doing with a recursive, remember with recursive, you always do A sub 1, your first term, so that's a 1 here, okay? And then it's A sub n equals, and it's always A sub n minus 1. In this case, we are multiplying by 10 each time, so that's your common difference, which is going to go here. Okay, so this is the recursive formula. The explicit formula, you do A sub n equals your first term and your common difference to the n minus 1 for the explicit. And then your 10th term, we would just plug 10 into the explicit formula. So it's going to be 1 times 10 to the 9th power, which is going to come out to a very large number, just like that. Okay, 9 zeros. 1 billion would be that number. Number 3, sorry, I kind of went into our space here. For number 3, the recursive, you're doing your first term, which is 3, followed by A sub n, which is always, again, A sub n minus 1, the term before it, times, and then we got to figure out what our common difference, or common ratio, did I say common difference on the last one? Common ratio is, we're multiplying by 2, right? So you would just go times 2 right there. So that's recursive. And then explicit would be A sub n equals, and then it's your first term times the common ratio to the n minus 1 power. So if we want the 10th term, we're just going to plug a 10 in there. So 3 times 2 to the 9th power, because we're plugging a 10 in for n. And that gets us, for our 10th term, 1,536. Okay. All right, page 7 is where we're going next here. This says find the first 5 terms in each arithmetic sequence. I think this one is just quick to plug them in. So 3 times 1 plus 2 would be the first term, 3 times 2 plus 2, 3 times 3 plus 2, 3 times 4 plus 2, and 3 times 5 plus 2. So you get 3 plus 2 is 5, 6 plus 2 is 8, 9 plus 2 is 11, 12 plus 2 is 14, and 15 plus 2 is 17. And then that would get you all of your terms. So 5, 8, 11, 14, 17 is your first 5 terms of the sequence. Number 8 and number 10 here, you are looking for arithmetic, geometric, or neither. And if you look at what is happening here, to get to your next term on all of these, it would be times 4. Okay, so that's geometric when you're multiplying. That does not look like an R, sorry. And then it asks you for the 9th term. So this is going to look just like those ones we just did. You're saying A of 9 is going to be your first term times the common ratio to the n minus 1. So if we're looking for our 9th term, it's going to be to the 9 minus 1, so to the 8th power. And if you plug that into your calculator, you get 196,608. Okay. And then this one, you have 10 and then 2 and then 2/5. So it's tempting to say you're dividing by 5, but it's a common ratio. So that would be multiplying by 1/5. So that is multiplication, and this is geometric. So then our setup would be our 9th term is going to be the first term times our common ratio to the n minus 1, so 9 minus 1, so to the 8th power. So you're taking 1/5 to the 8th power and multiplying by 10. And we're going to put that into scientific notation. So in scientific notation, it should be 2.56 times 10 to the negative 5th power. We had to move our decimal point 5 places to get to here. Okay, so that would be that one. All right, arithmetic and geometric mean. So the arithmetic mean, remember this is the one where we are adding. We're just finding an average. So we're going to go 16 plus 4 and divide by 2. So 20 divided by 2 is 10. The geometric mean, this is the one where we multiply the two numbers together and take the square root. So we're doing the square root of 16 times 4, which is the square root of 64, and the square root of 64 is 8. So that would be your geometric mean. If you come over to this one, the arithmetic mean, again, we're finding the average, so 25 plus 225, and then divide by 2. When you do that, you get 125. The geometric mean, again, we're multiplying them together, so 25 times 225, and then taking the square root of that. So that's going to come out to, if you plug that into your calculator, that would be 75. Okay. Find the sum of each finite series. So this one is saying we're going from 1 to 5 terms, and then we're adding them all together. So the first term, if we plug a 1 in here, 1 minus 1 is 0. The second term, if we plug a 2 in, 2 minus 1 is 1. If we plug a 3 in, 3 minus 1 is 2. If we plug a 4 in, 4 minus 1 is 3. And then if we plug the 5 in, 5 minus 1 is 4. So the sum is just adding those all up. So you have 7, 9, 10. So your answer here would be 10. Okay. Number 24, it says evaluate each infinite geometric series. So infinite being this one, right? The sum of the infinite series is a sub 1 over 1 minus the common ratio, okay? So if you look at this, a sub 1 is 12, and then it's 1 minus, and our common ratio here is you are multiplying by a half each time to get the next term. So it looks like this. So it's 12 divided by 1/2, essentially. So the sum to infinity would be 24. Okay. Then for this next one, if you look at how we're getting from one to the next, you are multiplying by a negative 1/5, right? It looks like you're dividing by -5. So you're multiplying by negative 1/5. So we have our first term, a sub 1, over 1 minus, and then it's our common ratio, negative 1/5. So that would be plus a positive. So it's 15 divided by 1.2 or 1 1/5, however you want to think of it. If you want, if decimal seems easier to you, call it 1.2. But what you get when you do that is the number 12.5. Okay. 28. Arithmetic or geometric, and then evaluate the finite series for the specified number of terms. So we are going to start by taking a look here, right? What are we doing to get to the next term? Each one of these is plus 4. So if it's plus 4, that means it's arithmetic. Okay, so that's the first part of our answer. And then it says to evaluate it. So we're doing the sum of an arithmetic finite series. So it's going to be the sum to 10 terms would be the number of terms over 2 times, and then it's your first term, which is 5, plus your last term. And that's what we need to figure out here. And if you remember, if we do the arithmetic series, that's the one that we take the first term plus n minus 1 times the common difference, which in this case is 4. So if we plug that in, our 10th term would be 5 plus 9 times 4, or 36 plus 5. So that would be 41. Okay, so that's our last term. That's what's going to go here in our formula. And so when we simplify that, you get 5 times 46, or 230. Okay, 29. For this one, again, you got to look at what you're doing. 35 to 70, 70 to 140, 140 to 280. Each time you're multiplying by 2. Okay, so if we're multiplying, that's a geometric sequence. And we're going to do the sum to 7. And for this one, because it's geometric, it's a different formula, right? We take our first term times, and then it's 1 minus our common ratio to the nth power. Okay, don't forget to put that parenthesis behind it. If you don't put that there, this doesn't work out nicely, okay? And then we're going to divide by 1 minus our common ratio again, and put parentheses around here again, okay? Or just notice that that's -1. So after you do this, divide by -1 is what you're doing. But when you plug that in, you should get 4,445 for your answer. Okay. Moving right along. Simplest form of this. So we are going to factor here. On top, we have what can you multiply to get 15 that you can add to get 8. And that would be 5 and 3. So that's going to be x plus 5 times x plus 3. On bottom, it's what can you multiply to get -12 that you can add to get -1. And that would be a -4 and 3. So that's going to be x minus 4 and x plus 3. Okay, well now think of it. This is your numerator. This is your denominator. Sorry, I should have put them over top of each other. This would be here. But the x plus 3's will go away. So you're left with x plus 5 on top and x minus 4 on bottom. And that would be letter G here. Okay. Number 8 here, f of x and g of x are given to you. What is the value of g of f of -8? So we start with f. Okay. We plug -8 into f. So it's going to be 4 times -8 plus 1. So this is -32 plus 1 is -31. Okay, and then they ask us to plug that into our g of x. So we plug -31 in right here. So it's 2 times -31 squared. So -31 squared, that comes out to 961, so it's 2 times 961, which is 1922, so that's letter F. I noticed that I did this wrong. I did it backwards. I gave you this as the answer in the answer key. That's wrong. So if you checked in on the answer key and were like, what? It was wrong, but I put that note in Canvas as well. So, all right, moving on. Okay, these ones, I don't like the way they word it because it's not exactly how we did it. I'm just going to show you some of the details. Center and intercepts, and then I asked for domain and range of each graph. I'll just kind of talk you through that. Your center here is 0, 0. Okay, the thing we would have noted here is what the radius is, and if you look 2, 4, and then halfway between, so our radius here is 5. When they talk domain and range, the furthest our x goes is -5 to 5. So you could say -5 is less than or equal to x, which is less than or equal to 5. And then your range, same thing. It goes as high as 5, it goes as low as -5. So technically that would be your range. Okay. Number 2, our center for this one is at 0, 0 again. Okay. Our x-intercepts would be here and here. So plus or minus 5 for your x value and a 0 for your y value. And then your y-intercepts here, you went up 3 and down 3, so it would be 0 and then plus or minus 3 on that one. And we'll leave it at that. For this one, again, your center is at 0, 0. And then we're going to say your vertices would be at -1 and 1, so plus or minus 1, 0. And we'll just leave it at that for that one. And then this one, your center is at 0, 0. Your vertices here are at 0, 3 and 0, -3, so 0 plus or minus 3, and we'll leave it at that for that one. All right, next one's write an equation of a parabola with a vertex at the origin and the given focus. Okay, so if it helps you, I mean, you can kind of draw it to visualize it if that's good for you. If we plot a focus at 0, 2, okay, this would be our focus, and it says vertex at the origin. So here's our vertex. That means our parabola is going to look like this. So it's going to be a y equals. Remember, if it's x equals, that's when it goes left and right. It's opening up, so it's going to be positive. Our c value here, right, this is our c length, that's 2 units. So we need to do a equals 1 over 4 times c. So a is going to equal 1 over 4 times 2, or 1/8. Okay, so we're doing y equals 1/8 times our x value squared. And that's the equation of a parabola. This one, it says our focus is at 4, 0. So 1, 2, 3, 4. And a vertex at 0, 0 means it's going to open like this. So now we're going to start with x equals something times y squared. And we just need to figure out what our a is. Again, we're going to use this a equals 1 over 4c. So a equals 1 over 4. And then our c value in this problem is 4, right? From the focus to the vertex, so 4 here. So that's 1/16. Notice it's opening to the right, that's positive. If it opened this way, it would be negative, but it doesn't. So positive, we would say 1 over 16 here, and that would be your answer. All right, number 10, find the center and radius. So center is always opposite of what it looks like here. So it's -2, -3. So it's going to be a +2, +3 for the center. And then your radius is the square root of this number. So your radius would be 4. Same thing here, opposite of what it looks like. Now there's nothing here, so that means the x value is 0. And then the y value looks like a +4, so it's actually a -4. So that's our center. And then our radius is the square root of that number. Well, that can be simplified to the square root of 4 times the square root of 2, or 2 rad 2. So that would be our radius. Okay. Now we do it the other way. Given the information, write the equation of the circle. So this is our h and our k, and this is our r. So it's going to be x minus h squared plus y minus k squared equals our radius squared, okay? So best answer, x minus 2 squared plus y minus 4 squared equals 9. And that would be your answer. All right, number 3 here, it asks you for the vertex, the focus, and the directrix. Remember when it's y equals, that's opening up and down. When this is positive, it's opening up. And there is no HK set up here, so your vertex is going to be at 0, 0. So it's going to be something like this, okay? So vertex at 0, 0. Our focus then, we know that A equals 1 over 4C, right? And my A value is 1/20th. So right now we're saying 1 over 20 equals 1 over 4C. You can cross multiply that, or you can just see that 4 times C has to equal 20. So C would be 5, okay, which means my focus is going to be up 5 units right here. That would be the point 0, 5. Okay, so that's my focus, which means my directrix line is going to be the horizontal line that same distance away down here. So a horizontal line, that's y equals, and now it's a negative 5, and that would be my directrix. All right, last page, and that is it for us, guys. Crazy, crazy, crazy. So find the vertices and foci of each equation, write the slope of the asymptotes for number 10, and then graph the equation and find the major and minor axes in number 9. Okay, so this first one, this is an ellipse, right? So we're going to look at this. Remember, your bigger one is your vertices. So in this one, that's the 16, right? That's a squared. So that means a is 4. So your vertices are at plus or minus 4, 0. Okay. That means your co-vertices are the other. So that's your b value would be 3. So that's going to be at 0 plus or minus 3 on that one. So if we plot those, you have plus or minus 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 3 and 3. That's 2, 3. There we go. So your ellipse looks something like this. We are going to find, does it ask? Yes, foci. So we're going to find the foci. Our center would be here, right? We have our A, well, our A and our B, or our A squared and our B squared. And this is, we're subtracting on this one, right? So it's C squared is going to equal 16 minus 9. So C squared is going to equal 7, which means our C is going to be the square root of 7, and that's going to get us our foci. So our foci are going to be plus or minus the square root of 7, 0. Okay, because remember, foci are by the vertices. So foci would be on this line, which is our major axis also. So our major axis is 4 and 4, so 8. And our minor axis is 3 and 3, so 6. All right, this one, this is a hyperbola now. And for the hyperbola, we have our b term. This is b squared, so our b would be 2. Our a term would be 6. So when we set this up, b is the vertical here, so 1, 2. And remember, the first one on a hyperbola is your vertices. So this is a vertex, this is a vertex. The second one is just helping you find your asymptotes and all of that stuff. So 6 to the right. Man, I keep doing my number in the wrong place. Sorry, 2. Let me go down 2. 1, 2. There we go. So those are our vertices, okay? But we also need to go 6 to the right, 6 to the left. So I'm going to do a different color here. 1, 2, 3, 4, 5, 6. Remember, that's not a point. 1, 2, 3, 4, 5, 6. It's just going to help us make our rectangle. So our rectangle is going to look like this. All right, so now our asymptotes, sorry, those aren't super straight here, will look like this. So our graph is going to be nearing those asymptotes, right? Like this and like this. So our vertices are at 0 plus or minus 2. And then our foci, for this one, it's subtraction, right? So our c squared equals a squared plus b squared is going to be our setup. So c squared is going to equal 4 plus 36, or 36 plus 4. They're going to get you the same thing. So c squared equals 40. And then we want to take the square root. So that's going to be the square root of 4 and the square root of 10, or 2 rad 10, for our c value. So that means our foci are going to be at 0 plus or minus 2 rad 10. Okay. And then it asks us for the slope of the asymptote for this one. Remember, this is just basically you finding the slope of a line. So if we're here and we need to get to here, we're going up to 1, 2, 3, 4, 5, 6. So up 2 over 6. Reduce that is up 1 over 3. So the equation for our asymptotes is y equals plus or minus, because we've got 2, right? This would be a negative, this would be positive, 1/3 times x. Okay. And that is everything we need on that one. All right. Write the equation of a hyperbola with the given characteristics. So this one we have vertices and we have foci. If your vertices are at 0 plus or minus 6, right? That's vertical here. So that means our y squared is going to go first, and then that's our b squared would be 36 minus, and then it's going to be x squared over something equals 1, and we need to figure out what that something is. So if you look here, this is our c value. C is going to be 8. We know b is 6. We need to figure out what a is. So with a hyperbola, you need to add your a squared plus b squared. So it's going to be a squared plus b squared equals c squared. Okay, so 64 and 36. So we're going to take away 36, and we get a squared equals, what is that, 28? And that's all we need is a squared, so you don't need to square root that. You would just drop it in right here. 28. Write an equation for a circle with the center 2, -3. So we know it's going to be x minus 2 squared and y minus a -3, so plus 3 squared. And then it's any radius squared, so it could be 16 was the example I gave you in the answer key. It could be 3 squared is 9. It could be 2 squared is 4. That's why it's open-ended. You could have any answer that makes sense right there. Okay. Number 3 here, which graph opens downward? When it's the x out in front of your a term, sorry, the negative out in front of your a term. So this versus nothing here versus this. The negative is going to open down. So that one would be our opening down. And then last 4 here, identify the conic section. So for this one, when it has x squared minus y squared, or it could be y squared minus x squared, that's the hyperbola. Okay, this one you have 25x squared plus 4y squared. So it's x squared plus y squared, but they're different numbers. That's the ellipse. This one, it's x squared plus y squared, and it's the same numbers. That's the circle. And this one just has one x squared, and that is a parabola. Okay, that is it, guys. You're done.